Calculate currents through various branches. The network is given, resistors are marked with their values, cells are also marked, and from 20 volt cell the current is coming in this way as I3, and at F we know I3 is entering and a current is flowing through this way as I1, and another current I2 that moves through this way. So I1 and I2 leaves the junction F, I3 enters the junction F. Incoming current is I3, outgoing currents are I1 and I2. So applying Kirchhoff's first rule, current rule at F, we know current entering the junction should be equal to the sum of currents leaving that junction. So I3 is equal to I1 plus I2. I3 equal to I1 plus I2. Now apply Kirchhoff's voltage rule to a particular loop. Suppose we are applying voltage rule to this loop A, B, C, F. This closed loop A, B, C, F back to A. So looking at this loop, we know the current is flowing in a particular direction. Through this loop, the current flows in one direction. Suppose say that is clockwise. Now according to voltage rule, we know the sum of potentials that should be equal to the EMF of that loop. So in this loop the EMF is 20 volt. So the potentials are 20 I3 and 10 I1, and both these potentials are created due to current flowing in the same direction. So both these potentials are given same sign. 20 I3 suppose it is positive, then 10 I1 also positive, and sum of potentials 10 I1 plus 20 I3 is equal to 20. Then I3 is equal to I1 plus I2. So 20 I1 plus 10 I1 will be 30 I1, like that. Then dividing throughout by 10, we got equation 1. Now applying Kirchhoff's voltage rule itself, but to the junction A, B, D, E, A. A, B, D, E, A. And here what are the potentials and what is the cell connected, that is 40 volt. EMF is 40 volt. We know according to this rule sum of potentials should be equal to EMF of the cell in that loop. EMF is 40. Now potentials, we know this way the direction of current I2. So the potential is 10 I2, but here we are finding a current flowing in the opposite direction. So this potential, if it is given positive sign, then potential due to current flowing in the opposite direction, that should be given negative sign. See this current this way, but I1 flows in a direction opposite to that of I2. So the current comes from this cell, so the potential is 10 I2, then minus 10 I1. Minus sign comes because that current is opposite in direction. So minus 10 I1, that is equal to 40. Dividing throughout by 10, so we got a minus of I1 plus I2 is equal to 4, equation 2. Now checking 1 and 2, comparing 1 and 2. See, suppose we are multiplying equation 2 by 3. Equation 2 is multiplied by 3. 3 into minus I1, minus 3 I1 plus 3 I2 is equal to 3 into 4, 12, equation 3. Now comparing equation 1 and 3. In 1 we have 3 I1 term, and equation 3 we have got minus 3 I1 term. So if 1 and 3 are added, this I1 terms can be eliminated. So 3 I1 plus minus 3 I1, that will be eliminated. 2I2 plus 3I2, that is 5I2. 2 plus 12, that is 14. So 5I2 is 14, I2 is 14 by 5. Now substituting the value of I2 in any of the above equations, suppose we are substituting it in first equation itself. So equation first is 3I1 plus 2I2 is equal to 2. So 3i1 is equal to 2 minus 2i2, 2 minus 2 into i2, i2 is 14 by 5. So we got it as 3i1 is equal to minus 18 by 5, i1 is equal to minus 6 by 5 ampere. So we got i1 and i2. i1 is this much and i2 is 14 by 5. So what is i3? According to Kirchhoff's first rule, we got i3 is equal to i1 plus i2. And substituting the value of i1 and i2, i1 is equal to minus 6 by 5 and i2 is equal to 14 by 5. So we are getting i3 as 8 by 5 ampere. So we calculated all currents through all branches.